Good evening, folks, and we are looking at the lab number 4, which is going to be the formation, hydrolysis of methyl salicylate, and the synthesis. We're not going to do acetylsalicylic acid. We're just going to make salicylic acid. I'm just using this as a template to look at here tonight. So essentially what we're going to be doing is doing the hydrolysis of methyl salicylate into salicylic acid. So that is basically the oil of wintergreen is what we will start from. That's our beginning material, which is an ester. Ester group has the OH group attached to a C double bond to an O, as you can see here. And then if you'll look at this, this is attached over to there's an alcohol group on this ring as well. If we put the sodium hydroxide in, and what that will do, and this one's only partial here, that will turn both of these O's into this O site and this O site into sites where they're both O's. So we're not seeing the whole thing here. We're actually seeing this product, and that's the salicylate ion. Now, there's sodiums associated with this. In essence, what we're going to do is take in very basic conditions, what we can do is both of those H's in extreme, heavily basic conditions will come off. Both of those H's will act acidic. So the acidic, which I believe is either a quiz or a question at the end of the lab, this H that's hanging here and this H that's hanging here are the two acidic protons. So both of those will be removed. And then, of course, acid-base reactions again. If we retreat the salicylic acid with a very harsh acid, sulfuric acid, these H's will reassociate in those positions, and they will create the salicylic acid group. So in this case, where this is in this case, this is not an H group here. This is a methyl group here, CH3 at this point. Then essentially what we're doing is removing that methyl group and replacing it and turning it into the salicylic, to the OH group, which turns it into a carboxylic acid. So salicylic acid looks like this. If we were to then mess with this, we could turn this into aspirin. That's another experiment, and you've probably already done that in some other class where you produced aspirin from salicylic acid. So we won't do that part. The amounts are not correct here, and I apologize. I'm in a location without my tool where I can write on the screen. We will use about 15 milliliters of 6 molar NaOH, and then you're going to use 10 millimoles here. You could probably from this figure out about how much that will be, and you're going to put those into a 100 milliliter. Let's make sure that's correct. Yes, we're going to do that in a 100 meter round bottom flask. That'll be in your kit. So the 100 milliliter round bottom flask has to fit into the next device. So what you will be doing at that point will be you will be taking it and you'll be adding what are boiling stones. Those are in the back of the room. Ours are usually Teflon, and these are materials that prevent what's called bumping. Large gas bubbles when you're heating or uneven boiling. These little stones give you nice, even little bubbling. You'll see how those work. So then you'll attach a reflux condenser to the top of the flask. Make sure you you go to the back of the text and you look at how to set up an apparatus for reflux. But if you're looking for what I'm trying to talk about, if you look at a reflux apparatus setup, it's pretty simple. We can look at this one. What you're going to have is the heating mantle. And the heating mantle, if we go look at it, is you should have one in your drawer. It looked like they put one in, but if we don't, we'll get you one. You can see the heating mantle. Your round bottom flask sits in the heating mantle. And then this attaches to a control where you can control your temperature. And then water will come in the reflux condenser, and it will go up, and then we'll go back out to the sink. So cold water is going to come in here, go up, and do this. So what we're going to do is put the chemicals into try to put the chemicals into the gas phase as much as we can, but they need to react with each other. So what we'll do is make them react in the gas phase, come up here, get cooled back down, they'll come into the condenser, and they'll keep doing this over and over, this cycle of becoming a gas and recondensing. So, and what that will do is give us a much faster reaction time. So you'll do that for a half an hour, doing this reflux. Don't start that part. I very well may be a tiny bit late for class on Thursday, and if I am, I know you guys can probably get in, and it's okay if you want to set up the apparatus and everything, but do not start the experiment until I get there and check your apparatus, just to make sense. So then you'll reflux it for a half an hour. After that half-hour period, you'll transfer the material inside to a beaker, and you take all the materials out of it. When you get to that time, um, if you have heated it for 30 minutes and there is there's still an oily liquid or a solid in there, keep heating until it's gone. Remove it, take it out, and then add about 16 milliliters you're going to add 16 milliliters of 3 molar sulfuric acid to it. Then test the top part of the liquid with pH paper. And if it's not below 2, keep adding uh, the sulfuric acid until you get to below 2. Then you should see the salicylic acid precipitate. Cool that in an ice bath. Get your maximum amount you can. Get that in a slurry. Pour it through the Buchner funnel. And then we will set it up and we will recrystallize from water. So you'll have to measure your amount. You'll have to look at your solubilities. You have to do those calculations like we did in the last lab, but you have to do them for your material this time. And then what you do is filter that, dry it, and we'll probably wait till the following week to get your melting point to see if you have produced the salicylic acid. So our point here this time is that what we're trying to do is kind of combine everything we've done so far and put it all together into one experiment. So we will react. We will now do the new thing, which will be the refluxing for a half an hour. Then you'll return your material back into an insoluble substance, precipitate it, wash it on the filter, then recrystallize it, then get its melting point. So really, pretty simple experiment from that standpoint. Questions for this lab are going to be from the end, of course, of the section. It'll be 1, 2, 4, and 5. And it's a pretty straightforward experiment. I would suggest you look at page 66 in the text. And on page 66 in the text, you will see that there is a setup in there where you might want to fill in the numbers in that setup so that you have a reasonable opportunity to know what you need when in the experiment. So make sure you can get a reflux column set up, and we're hoping we have everything there for us, so we'll be able to hook them all up. We don't have that part right now with only one sink at each table, so we may have to do it in shifts. We'll see what we can do with that. We hope everything's done for us on Thursday. So I'll see you Thursday, and we'll go from there. Thanks.